look at some of the basics of relations. The first question, what is a relation? A relation from a set A to a set B is a subset of A cross B. And we denote A RB means that the point A comma B is in our relation. The main point here is the first coordinate of our ordered pair needs to come from A, the second coordinate needs to come from B. We'll look at a couple of these and different ways we can represent them. Here I have a set ABC and then a second set 0, 1, 2, 3, 4. And we have a list of ordered pairs here that belong to our relation. It's not all ordered pairs that can be formed, it's just a subset of them, and that's all that matters. We're going to look at two different ways we can represent these relations. The first is called an arrow diagram. Essentially, I'm going to start with two bubbles, and in each side of them, the first one will represent the elements of A. The second one will have our elements of B. 0, 1, 2, 3, and 4. And essentially, we're going to draw an arrow if that point is in there. A1 means we draw an arrow from A to 1. A4 means we draw an arrow from A to 4. B0, we draw an arrow from B to 0. 1 from B to 2, and 1 from B to 4. And then the last one, C to 3. This is our arrow diagram. We can also have a table. And if we have a table, across or down the side goes our first set, ABC. Across the top is our second set, 0, 1, 2, 3, and 4. And we put an X in the corresponding spot if that point is in there. A1 and A4. We have B0, B2, and B4. We also have C3. So here is our table. We will be most interested in what are called relations on a set. And these are relations from a set A to that same set. So it's a relation from one set to itself. Therefore, all of the points in the first coordinate can be the same as the points in the second coordinate. And these are the ones that we'll be looking at from now on. Let's consider this relation. The set A, 1, 2, 3, 4, 5 equal to, and the relation is given by, the set A comma B means that A divides B. We'll start with putting this in an arrow diagram. The fact that it's a relation from A to A means that both of these bubbles will look the same to start with. So 1, 2, 3, 4, 5 goes in both of them. And now we need to think about which points satisfy our condition. The first thing is a 1, so we want to know what numbers does 1 go into evenly. Well, 1 can divide into 1, into 2, 3, 4, and 5. What about 2? Well, 2 can go into 2, and it can also go in evenly into 4. 3 can go into 3, 4 can go into 4, and 5 can go into 5. We can see that this thing is starting to get a little out of hand. And essentially, the more ordered pairs in your relation, the more it can be difficult to read. This is one reason why we do have these other ways to represent, like our table. Since it's the same set, we have them going up and down the side. We have 1 divides 1, 2, 3, 4, and 5. 2 divides into 2 and 4. 3 goes into 3, 4 goes into 4, and 5 goes into 5.